Now going to determine the oxidation number of any element. Particularly, we are discussing these elements, those who are used in day-to-day chemistry life. So, first let me clarify what is oxidation number. Second topic, after detection of this oxidation number, we are going to find out how the chemical formula is set out. So total we are discussing here two topics in this chapter. So let us start one by one. So first, before start, it must be very clear that you must aware about atomic number, you must aware about periodic table, and then we can able to discuss these all things here. So let us start. First, what is oxidation number? You might have noticed that many times we are writing elements like, say for example, Na+1, Ca+2, Al+3. So like that things we are writing out. So this is whatever we are writing on head, that is called as oxidation number. Now, in case of Cl, we are writing -1. In case of O, we are writing -2. In case of certain radicals like fluorine, chlorine, bromine, iodine, we are writing -1. So all these things, what we are writing on top, that is called as oxidation number. You are aware that when you are talking about valency, what is that? That in simple language, number of electrons either donated or accepted or shared. I am revising. Valency is number of electrons either donated or accepted or shared in order to complete octet in the last shell. Octet means 8 electrons if it is second shell onwards, and for first shell we are calling it as diplet. So what is the meaning of this all? So this is actually, we are starting with some different rule that is called as octet rule. So every element, according to this rule, every element tries to complete inert gas configuration. One more word I have to add, nearest inert gas configuration. So, so either by accepting or by donating or by sharing out of electron. So in short, valency, that means number of electrons accepted, donated or shared in order to complete either 8 electrons from second shell onwards or 2 electrons for first shell if it is last shell. Okay. Now let us take an example of, say, sodium chloride. So sodium is having electronic configuration as 281. Just try to recollect our atomic structure chapter. Atomic number of sodium is 11. So first shell 2 electrons, second shell 8, last shell 1 electron. So sodium can either accept 7 electrons, so it will be 288. It can donate 1 electron, so it will be 28. Or it can share out 1 electron, or it can share out 7 electron. Anything is possible out of this probability. But the most feasible probability, that is donation of 1 electron. That is the easiest one. Now, in case of sodium, we have clear-cut idea sodium wants to donate electron. But to whom? So there must be some acceptor. Now let us check out chlorine. Chlorine is having electronic configuration 287. As its atomic number is 17, we can check out 287. Now, chlorine can accept 1 electron, so 288. Chlorine can donate 7 electron, or can share 7 electrons, or can share 1 electron. Out of that, the most probable thing, that is to accept 1 electron, is comparatively easier task. Now here there is a donor, that is sodium. There is acceptor, that is chlorine. So sodium will donate 1 electron, chlorine will accept 1 electron. As a result, you can check out that sodium, as it donates 1 electron, it is having now 10 electrons, but net number of protons remains same, because protons, they are there in the nucleus. And unless there is nuclear reaction, or nuclear disintegration, proton number can be changed. And therefore, number of proton in case of sodium will remain same. And you are aware, if proton number is changed, then obviously name of element is also changed. And therefore, we have to keep that number as constant. So there are 11 protons in sodium, whereas now 10 electrons. So 11 proton will contribute plus 11 charge, whereas 10 electrons will contribute minus 10 charge. So sum net total, that will be plus 11 minus 10, that will be plus 1. And you are aware that atom is electrically neutral, and therefore we have to call this particle as a with different name. That different name is ion. So this way we are getting this ion. So sodium atom is converted into sodium ion. Clear? So here we have now conversion of sodium atom into sodium ion because of donation of electron. Now same way, just check out about chlorine. Chlorine is accepting out 1 electron. As a result, chlorine is having now 18 electron, whereas chlorine is having 17 protons. We are aware proton number can't be changed. So chlorine is having 17 protons but 18 electrons. As a result, net charge, that is plus 17 minus 18, that will be equal to minus 1. So I can call now chlorine as an atom. So we are giving different name, that is called as ion. Now this is negative ion, whereas sodium ion is positive, and you are aware there is strong attraction between positive and negative. As a result, both ions bound together. We are naming this type of bond is ionic bond. Actually scientific name, that is electrovalent bond. But in general practice, we are calling this as an ionic bond. So here we'll get oxidation number of sodium is plus 1 as it donates 1 electron. Oxidation number of chlorine is minus 1 as it accepts 1 electron. We can consider about calcium and chlorine. So let us check out electronic configuration of calcium. You are aware atomic number of calcium is 20. Just try to recollect our periodic table chapter. We have discussed there that you must by heart minimum atomic number 1 to atomic number 20, all elements with their name. So this is calcium, atomic number 20, simple level electronic configuration 2882. So last shell contains 2 electrons. Now you are aware that it should donate 2 electrons, or it should accept 6 electrons, or it should share 2 or 6 electrons, either of. So again, it's easy to donate 2 electrons. So electronic configuration will be 288 in case of calcium. Now calcium is ready to donate 2 electrons, but who is there to accept? So let us take example of chlorine. You are aware now electronic configuration is 287. Last shell is having 1 electron short, but calcium is having 2 electrons extra. So calcium will donate 2 electrons, but chlorine is not having space to accept another electron. So another chlorine will accept that electron. So totally 2 chlorine atoms, they are required to accept 2 electrons from calcium. As a result, calcium is only single atom, but chlorine 2 atoms are required. Now you are aware that on donation of electrons, means calcium is having 20 protons and 18 electrons. So 20 proton plus 20 charge, 18 electron minus 18 charge, total plus 20 minus 18, that will be plus 2. So I can't call this as atom because this is having now charge, and so we are calling it as an ion and having plus 2 charge. So oxidation number of calcium here is plus 2. But chlorine, again, it accepts only 1 electron. So oxidation number is minus 1. Whereas 2 chlorine atoms are there, though they are accepting 1 electron each. So net oxidation number of both the chloride ions is minus 2, but singly it is only minus 1. So this way you can check out calcium chloride molecule is formed. So now you are aware how this ionic bond is formed, or rather I should name this as